Tonight, we're embarking on a celestial voyage to one of the most enchanting worlds in our solar system, Saturn. That magnificent ringed giant floating serenely in the outer reaches of space. Before we begin drifting through Saturn's symphony of rings, moons, and mysteries, I'd love to know where in the world you're listening from tonight and what time it is in your corner of the universe. There's something beautifully fitting about exploring Saturn together. Each of us scattered across Earth's time zones while contemplating this distant world that has captivated humanity for centuries. If you find tonight's journey through the Saturn system soothing or fascinating, I'd be ever so grateful if you gave this video a gentle like, perhaps subscribed, or simply left a comment sharing your thoughts. It helps this quiet corner of space science reach other stargazers who might need a peaceful pause in their evening. Now, I do hope this isn't so mesmerizing that it keeps you awake, but if it does, well, at least you'll drift off knowing a bit more about one of the solar system's most spectacular performers. So settle in, let your breathing slow, and prepare to float alongside Saturn as we explore its glorious rings, its fascinating family of moons, and the countless mysteries that still whisper to us across nearly 1 billion miles of space. Somewhere between the gentle tug of gravity and the dance of ice and rock lies a story as old as the solar system itself. And tonight, that story is ours to discover. Saturn has been humanity's mysterious companion in the night sky for as long as people have looked up at the stars. To ancient civilizations, it was the slowest wandering star, taking nearly 30 Earth years to complete its stately procession through the zodiac. The Babylonians called it Ninurta, after their god of agriculture and war. The Greeks named it Kronos, the Titan of time, perhaps because of its unhurried journey across the heavens. But it wasn't until 1610 that Galileo Galilei first turned his primitive telescope toward Saturn and saw something that would puzzle astronomers for decades. What Galileo observed looked like a planet with handles or ears, strange protrusions that seemed to come and go depending on when he looked. His telescope wasn't powerful enough to resolve Saturn's rings clearly, so he described what he saw as a triple planet, with 2 smaller companions flanking the main body. Imagine his confusion when he looked again 2 years later and found that Saturn's companions had seemingly vanished. Poor Galileo wrote in frustration that Saturn had devoured its own children, not knowing that he was witnessing the rings edge on when they become nearly invisible from Earth. It wasn't until 1659 that Dutch astronomer Christian Huygens, using a more powerful telescope, finally solved the mystery. He proposed that Saturn was surrounded by a thin, flat ring that didn't touch the planet anywhere. This was a revolutionary idea at the time, something unlike anything else known in the solar system. Huygens wrote his discovery in the form of an anagram, a common practice to establish priority while keeping the discovery secret until more observations could be made. When decoded, his Latin phrase revealed the truth that would captivate humanity for centuries to come. As telescopes improved through the centuries, Saturn's ring system revealed more and more complexity. Giovanni Cassini discovered that what appeared to be a single ring was actually divided into multiple bands, separated by what we now call the Cassini division, a gap nearly 5,000 kilometers wide. More divisions appeared as technology advanced, and what once seemed like a simple ring became an intricate system of thousands of individual ringlets, each with its own orbital characteristics and composition. But Saturn's allure extends far beyond its magnificent rings. Through those same telescopes, astronomers began discovering Saturn's moons, an ever-growing family of natural satellites that would eventually number more than 80. Huygens himself discovered the first and largest, Titan, in 1655. Others followed Iapetus, with its mysterious two-toned coloration, Rhea, Dione, and Tethys, each adding to the complexity and wonder of the Saturn system. For 3.5 centuries, Saturn remained a distant mystery, a beautiful jewel in the night sky that could only be admired from afar. Then, in the space age, everything changed. The Pioneer and Voyager missions of the 1970s and 1980s gave us our first close-up views of Saturn, revealing a world of breathtaking beauty and unexpected complexity. The rings weren't solid disks, but countless particles of ice and rock, some as small as dust grains, others as large as houses, all locked in an intricate gravitational dance. The Voyager encounters showed us Saturn's moons in detail for the first time. Titan, shrouded in a thick orange atmosphere, became a world of particular fascination. Enceladus, small and icy, showed signs of recent geological activity. Each moon told its own story, shaped by billions of years of interaction with Saturn's powerful gravitational field and the complex dynamics of the ring system. But it was the Cassini mission, launched in 1997 and arriving at Saturn in 2004, that truly opened our eyes to the wonders of this distant realm. For 13 years, Cassini orbited Saturn, taking hundreds of thousands of images, measuring magnetic fields, analyzing atmospheric composition, and studying the intricate relationships between the planet, its rings, and its moons. The mission culminated in 2017 with Cassini's dramatic final plunge into Saturn's atmosphere, a grand finale that provided our most detailed look yet at the planet's interior structure. Tonight, as we begin our gentle exploration of Saturn's realm, we carry with us the accumulated knowledge of centuries of observation and discovery. From Galileo's first puzzled glimpse to Cassini's final transmission, each observation has added another note to Saturn's cosmic symphony. We know now that Saturn is not just a planet with rings, but an entire system of worlds, each with its own personality, its own mysteries, and its own role in the grand celestial dance that has been playing out for billions of years. Saturn itself is a giant among planets, the second largest in our solar system after Jupiter, yet it possesses a unique character all its own. While Jupiter is often called the king of planets for its sheer size and dominance, Saturn might be considered the system's most elegant member, a graceful giant adorned with the most spectacular ring system known to science. If you could somehow place Saturn in a cosmic ocean, it would float, being the only planet in our solar system less dense than water. This remarkable characteristic comes from its composition, a world made primarily of hydrogen and helium, the lightest elements in the universe. Saturn's structure is a study in layers, like a cosmic onion wrapped in atmosphere. Deep within, there may be a rocky core, perhaps 10 to 20 times the mass of Earth, composed of rock, ice, and metals compressed under unimaginable pressure. Surrounding this core is an ocean of metallic hydrogen, a state of matter that doesn't exist naturally on Earth, where hydrogen atoms are squeezed so tightly that they behave like a liquid metal. This exotic material generates Saturn's magnetic field, creating an invisible shield that deflects the solar wind and traps charged particles in radiation belts around the planet. Above the metallic hydrogen lies an ocean of molecular hydrogen and helium, gradually transitioning into the planet's atmosphere. This atmosphere is where Saturn's visible character emerges, a world of swirling clouds, powerful winds, and subtle beauty. Unlike Jupiter's bold bands of red, brown, and white, Saturn presents a more muted palette, soft golds and pale yellows that speak of a gentler, more serene world. But don't let this peaceful appearance fool you. Beneath those calm-looking clouds, winds rage at speeds that would dwarf any earthly hurricane, reaching velocities of up to 1,800 kilometers per hour. Saturn's atmosphere is a complex weather system, driven by the planet's internal heat. Remarkably, Saturn radiates more than twice as much energy as it receives from the Sun, glowing from within like a dying ember. This internal heat source, left over from the planet's formation 4.5 billion years ago, drives the atmospheric circulation that creates Saturn's weather patterns. The planet's rapid rotation, just over 10.5 hours for a complete day, stretches these weather systems into the banded structure we observe. Though Saturn's bands are more subtle and delicate than Jupiter's bold stripes. One of Saturn's most remarkable features is found at its North Pole, a geometric marvel that defies easy explanation. There, swirling in the upper atmosphere, is a hexagonal cloud formation, a six-sided storm system larger than Earth itself. This hexagon, first glimpsed by Voyager and studied in detail by Cassini, is unique in the solar system. No other planet displays such a perfectly geometric atmospheric feature. The hexagon rotates with the planet, maintaining its shape for decades, a testament to the stable and mysterious dynamics of Saturn's atmosphere. At the hexagon's center sits another wonder, a massive hurricane-like storm with an eye reminiscent of earthly hurricanes, but far larger and more persistent. This polar storm, like the hexagon that surrounds it, seems to be a permanent feature of Saturn's atmosphere, a cosmic weather system that has been raging for perhaps millions of years. The combination of the hexagonal cloud formation and the central storm creates one of the most striking and mysterious sights in the solar system. Saturn's seasons are long and subtle, each lasting about 7 Earth years as the planet slowly orbits the Sun. During its 29-year journey around our star, Saturn's rings and moons experience changing illumination, creating a slow-motion light show that has fascinated astronomers for centuries. When Saturn's rings are tilted toward Earth, we see them in all their glory, spread wide like a cosmic dinner plate. When they're edge-on, they nearly disappear, becoming a thin line barely visible in even the most powerful telescopes. The planet's magnetic field adds another layer of complexity to Saturn's character. While not as strong as Jupiter's, Saturn's magnetosphere is still formidable, extending millions of kilometers into space and interacting with the solar wind, the planet's rings, and its many moons. This magnetic field creates auroras at Saturn's poles, ghostly curtains of light that dance in the planet's upper atmosphere, powered by charged particles trapped in the magnetosphere. Perhaps most remarkably, Saturn sings. The planet's magnetic field and its interaction with charged particles create radio emissions that, when converted to sound, produce an eerie, haunting melody. These radio waves, detected by spacecraft like Cassini, give Saturn a voice, a cosmic song that has been playing for billions of years in the silence of space. It's a reminder that even in the apparent emptiness of the solar system, there are invisible symphonies playing out on scales we can barely comprehend. As we drift deeper into our exploration of Saturn's realm, we carry with us the image of this magnificent world, a giant planet of subtle beauty and hidden complexity. Saturn is more than just a backdrop for its famous rings. It's a dynamic, evolving world with its own personality, its own mysteries, and its own role in the grand story of our solar system. From its floating density to its geometric storms, from its internal heat to its invisible songs, Saturn reminds us that the universe is full of wonders that challenge our understanding and inspire our sense of cosmic wonder. If Saturn is the crown jewel of our solar system, then its rings are surely the crown itself, a breathtaking display of cosmic architecture that has captured human imagination for centuries. These rings, spanning hundreds of thousands of kilometers, yet often thinner than a city block, represent one of nature's most elegant solutions to the complex dance of gravity, motion, and time. Tonight, as we float gently through this cosmic jewelry box, we'll discover that Saturn's rings are far more than the simple bands they appear to be from Earth. The ring system extends from about 7,000 kilometers above Saturn's cloud tops to more than 120,000 kilometers from the planet's center. Yet the main rings are remarkably thin, in some places only about 10 meters thick. Imagine a disk the size of the distance from Earth to the Moon, but thinner than a multi-story building. This incredible thinness is maintained by the gravitational influence of Saturn's moons, which act like cosmic shepherds, keeping the ring particles confined to narrow bands and preventing them from spreading out into space. What we call Saturn's rings are actually thousands of individual ringlets, each following its own orbital path around the planet. From Earth, these appear as distinct bands separated by gaps, the most famous being the Cassini division, a 4,700-kilometer wide gap between the A and B rings that's visible through a good telescope. But Cassini's close-up observations revealed that even these apparently empty gaps contain faint rings, and that the rings themselves are incredibly complex structures, with waves, spokes, and braided patterns that change over time. The rings are composed primarily of water ice, ranging from tiny particles no bigger than dust grains to chunks as large as houses. This ice isn't pure. It's mixed with rocky material and organic compounds that give the rings their subtle coloration. The B ring, the brightest and most massive of the main rings, appears brilliant white in sunlight, while the A ring has a slightly yellowish tint. The faint C ring, closer to Saturn, is nearly transparent, allowing us to see the planet's disk through it, like looking through cosmic gauze. Each ring particle is essentially a tiny moon, following its own orbit around Saturn according to Kepler's laws. Particles closer to Saturn orbit faster than those farther out, creating a shearing motion that prevents the rings from solidifying into a single structure. This differential rotation also creates the beautiful spiral density waves that ripple through the rings like frozen music, patterns that form and dissolve in response to gravitational resonances with Saturn's moons. Some of the most mysterious features in Saturn's rings are the spokes, dark radial markings that appear to rotate with the planet's magnetic field rather than following orbital motion. First discovered by Voyager, these spokes seem to be composed of tiny charged particles that are lifted above the ring plane by electromagnetic forces. They appear and disappear on timescales of hours, creating a dynamic, ever-changing pattern that adds to the ring's mysterious beauty. The origin of Saturn's rings remains one of the great puzzles of planetary science. One theory suggests they formed from the destruction of a large moon that wandered too close to Saturn and was torn apart by tidal forces. Another possibility is that they're the remnants of the solar system's formation, primordial material that never coalesced into a moon. Recent studies suggest the rings might be relatively young, perhaps only 100 to 200 million years old, making them younger than the dinosaurs on Earth. The rings are not permanent features. They're slowly spiraling into Saturn, raining down onto the planet's atmosphere in a process that gives Saturn's upper atmosphere a slight glow. At the current rate of ring loss, the main rings might disappear entirely in another 100 million years, making us incredibly fortunate to live at a time when we can witness this cosmic spectacle. In the grand timeline of the solar system, Saturn's rings are a brief but magnificent display, a cosmic flower blooming and fading on timescales vast beyond human experience. Perhaps most remarkably, the rings create their own weather. The Cassini spacecraft observed lightning-like discharges in the rings, probably caused by collisions between ring particles. There are also seasonal changes as Saturn's 29-year orbit carries the rings through different orientations relative to the Sun, causing temperature variations that affect the ring particles' behavior and appearance. The rings also sculpt space around Saturn, creating gaps and resonances that influence the orbits of the planet's moons. Some small moons, called shepherd moons, orbit just outside the rings and use their gravitational influence to keep ring particles confined. Others, like Pan and Daphnis, orbit within ring gaps, creating wakes and waves in the surrounding material like boats moving through water. As we drift through this cosmic architecture, it's worth remembering that we're witnessing something incredibly rare. Of all the planets we've discovered, both in our solar system and around other stars, prominent ring systems like Saturn's are uncommon. Jupiter, Uranus, and Neptune all have rings, but none approach the grandeur and complexity of Saturn's system. We live in a special time and place, able to look up at the night sky and see this wonder, a reminder of the incredible diversity and beauty that exists in our cosmic neighborhood. Tonight, as Saturn's rings catch the distant sunlight and cast their faint shadow on the planet below, we're reminded that the universe is full of temporary masterpieces, structures of incredible beauty that exist for just a moment in cosmic time. Now here we are, fellow cosmic travelers, standing at the edge of what we know, peering into the vast unknown of Saturn's realm. We've traced the gentle arc of discovery from those first blurry glimpses through Galileo's modest telescope to the breathtaking revelations of modern space missions. We've marveled at the delicate architecture of rings that span the width of continents, yet remain thinner than a city block, and we've felt the gravitational poetry of dozens of moons dancing in their ancient, ordained patterns. But Saturn, as we've seen, is more than just a collection of fascinating facts. It's a living system, a cosmic symphony where every ring particle, every moon, every swirling storm plays its part in an orchestration that has been unfolding for billions of years. The hexagonal storm at Saturn's North Pole spins with geometric precision that would make a mathematician weep. The shepherd moons tend their ring boundaries with the patience of cosmic gardeners. And deep within that golden atmosphere, metallic hydrogen flows in currents we can barely imagine, generating magnetic fields that paint auroras across polar skies in colors no human eye will ever see directly. What strikes me most profoundly about Saturn is how it challenges our earthly intuitions about permanence and solidity. Those magnificent rings, which seem so eternal in photographs, are actually ephemeral on cosmic timescales. They're raining down onto the planet even now, particle by particle, giving Saturn perhaps only a few 100 million more years to wear this spectacular crown. In the deep future, Saturn may be just another gas giant, beautiful in its own right, but lacking the ethereal rings that make it the jewel of our solar system today. This impermanence doesn't diminish Saturn's wonder, it amplifies it. We are witnessing something precious, something that won't last forever. Every image from Cassini, every measurement of ring dynamics, every discovery about moon interactions captures a moment in an ongoing story. Saturn's rings may have formed from the destruction of an ancient moon, or they may be primordial remnants from the solar system's birth. Either way, they remind us that even in the vastness of space, beauty is fragile and change is constant. The moons of Saturn tell their own stories of transformation. Enceladus, with its tiger-striped fractures, shoots geysers of water ice into space, creating a tenuous atmosphere and contributing material to Saturn's E-ring. Titan, shrouded in its thick orange haze, harbors lakes of liquid methane and ethane under skies that rain hydrocarbons. Europa may hide an ocean beneath its icy shell, while Iapetus wears its mysterious equatorial ridge like a cosmic walnut. Each moon is a world unto itself, shaped by forces we're only beginning to understand. Perhaps most humbling of all is how Saturn reveals the interconnectedness of celestial mechanics. The gravitational resonances that create gaps in the rings are the same mathematical relationships that govern the orbits of planets around other stars. The tidal forces that heat Enceladus's interior are cousins to the forces that create Earth's ocean tides. The atmospheric dynamics that drive Saturn's storms follow principles we can observe in Earth's weather, just scaled up to planetary proportions and powered by different chemistry. Saturn teaches us that the universe operates according to elegant physical laws that manifest in endlessly creative ways. Gravity sculpts rings with the same patient artistry it uses to form galaxies. Electromagnetic forces that power our technology also create the charged particle interactions that make Saturn's auroras dance. The same thermodynamics that governs your morning cup of tea also drives the convection patterns in Saturn's massive atmosphere. And yet, for all our scientific understanding, Saturn retains an essential mystery. We can measure its magnetic field strength and map its ring structure, but we cannot fully capture the awe of seeing those rings edge on, appearing as a thin line of light bisecting the planet's disk. We can analyze the spectroscopic signatures of Titan's atmosphere, but we cannot quite fathom what it would feel like to stand on that distant shore beside a methane sea, looking up at Saturn hanging huge and golden in an alien sky. This is perhaps the most beautiful aspect of Saturn's story. It bridges the quantitative and the qualitative, the measured and the mysterious. It satisfies our desire to understand while simultaneously inspiring our capacity for wonder. In Saturn's realm, science and poetry converge. The equations that describe orbital mechanics become verses in a cosmic song. The physical processes that govern ring dynamics become movements in a celestial ballet. As we drift toward the end of our journey through Saturn's domain, take a moment to appreciate where we've traveled. We've explored a world where storms larger than Earth rage for centuries, where moons shepherd ring particles with gravitational precision, where water geysers shoot hundreds of kilometers into space, and where the very concept of solid ground gives way to layers of gas and liquid that transition imperceptibly into one another. We've learned that Saturn's beauty isn't just skin deep, it's structural, emerging from the fundamental physics of matter and motion, gravity and electromagnetism, heat and cold. The rings aren't just pretty. They're a natural laboratory for understanding how particles interact under the influence of gravity and electromagnetic forces. The moons aren't just diverse. They're laboratories for studying geology, atmospheric science, and potentially even biology in environments radically different from Earth. Saturn reminds us that we live in a universe of almost incomprehensible richness and complexity. In our own solar system, within the realm of a single star, we find worlds of ice and rock, atmospheres of hydrogen and methane, rings of water, ice, and organic compounds, magnetic fields and radiation belts, geysers and storms and aurora. If such diversity exists in our cosmic neighborhood, what wonders await discovery around other stars, in other solar systems scattered across the galaxy? But perhaps most importantly, Saturn reminds us of our place in this grand cosmic story. We are observers, yes, but we are also participants. The same stellar processes that forged Saturn's metals and organic compounds also created the elements in our bodies. The same gravitational forces that shape Saturn's rings also keep our planet in its life-sustaining orbit around the Sun. We are not separate from the cosmos we study. We are expressions of it, temporary arrangements of matter and energy that have become conscious and curious about their own origins. So as you settle into sleep tonight, perhaps you'll dream of golden rings catching starlight, of moons locked in gravitational dances older than complex life on Earth, of storms that dwarf our planet and auroras that paint alien skies in impossible colors. Perhaps you'll imagine standing on the observation deck of some future spacecraft, watching Saturn grow larger and more magnificent as you approach, its rings resolving from a distant line of light into countless individual particles, each one a tiny world with its own story to tell. And perhaps, in the quiet moments before sleep takes you, you'll feel a gentle sense of connection to this distant, beautiful world. Not just intellectual connection, but something deeper, a recognition that Saturn and Earth and you and I are all part of the same cosmic story, all products of the same stellar alchemy, all dancers in the same gravitational ballet that has been playing out across space and time for billions of years. Saturn's symphony continues, its rings still shimmering, its moons still dancing, its storms still raging in their majestic, measured way. And somewhere in that vast orchestration, there's a place for wonder, for curiosity, for the quiet joy of understanding just a little bit more about the beautiful, mysterious universe we call home. Sleep well, fellow travelers. We've already traveled through the cosmos, watching galaxies birth themselves from primordial darkness, and witnessed how Saturn's rings dance in gravitational harmony. Now, as we drift deeper into our celestial journey, let us turn our attention to Saturn's most enchanting companions, its moons. Like characters in an ancient mythology, each moon tells its own story, harbors its own secrets, and contributes to the grand symphony we call Saturn's domain. Saturn doesn't just wear rings like cosmic jewelry. It hosts a family of at least 146 known moons, each one a world unto itself. Some are tiny, irregular chunks of rock and ice, captured asteroids that found themselves drawn into Saturn's embrace. Others are substantial spheres, large enough to have atmospheres, weather systems, and perhaps even the ingredients for life. Together, they form one of the most diverse and fascinating collections of natural satellites in our solar system. Let's begin with Titan, Saturn's largest moon and the second largest moon in the entire solar system. Titan is remarkable not just for its size, but for being the only moon we know of with a thick atmosphere and stable bodies of liquid on its surface. When the Cassini mission first peered through Titan's orange, hazy atmosphere using radar, it revealed a world that looked strangely familiar. Lakes, rivers, shorelines, and even what appeared to be islands. But this isn't water we're looking at. Titan's surface temperature hovers around -179 degrees Celsius, cold enough that water becomes as hard as rock. Instead, Titan's lakes and rivers flow with liquid methane and ethane, hydrocarbons that remain liquid at these frigid temperatures. Picture, if you will, standing on Titan's surface. The sky above would glow a perpetual orange twilight, thick with nitrogen and methane clouds. The gravity, about 1/7 that of Earth, would make you feel impossibly light. And stretching before you might be a vast lake of liquid methane, its shores carved by eons of hydrocarbon rain. Seasons on Titan last about 7 Earth years, and during Titan's spring and summer, methane storms can rage across the landscape. filling the lakes and carving new channels in the icy bedrock. It's a complete weather cycle, a hydrological system, but built from entirely different materials than anything we experience on Earth. Beneath Titan's icy crust, scientists believe there exists another ocean, this one made of liquid water mixed with ammonia. This subsurface ocean might be more voluminous than all of Earth's oceans combined, and it raises tantalizing questions about the possibility of life. Could organisms exist in that dark, hidden sea, warmed by tidal heating as Titan orbits Saturn? We don't know yet, but the possibility makes Titan one of the most intriguing targets for future exploration. Moving inward towards Saturn, we encounter Enceladus, a moon that has revolutionized our understanding of where life might exist in the solar system. Enceladus is small, only about 500 kilometers in diameter, and from a distance it appears as a brilliant white sphere reflecting sunlight off its pristine, icy surface. But Enceladus holds a secret that wasn't discovered until the Cassini spacecraft flew close enough to investigate strange readings in Saturn's magnetic field. At Enceladus's south pole, something extraordinary is happening. Great geysers of water vapor and ice particles shoot hundreds of kilometers into space from parallel fractures in the surface called tiger stripes. These aren't just any geysers. The water contains salt, organic compounds, and tiny silicate particles that could only come from interactions between water and rock on the ocean floor. This tells us that beneath Enceladus's icy shell lies a global ocean of liquid water, and that this ocean is in contact with a rocky core where chemical reactions that could support life might be taking place. The energy driving these geysers comes from tidal heating. As Enceladus orbits Saturn in an elliptical path, the varying gravitational pull stretches and compresses the moon's interior, generating heat through friction. It's the same force that keeps Jupiter's moon Io volcanically active, but on Enceladus, it maintains a liquid ocean beneath the ice. The discovery of these water plumes has made Enceladus one of the most promising places to search for extraterrestrial life. A tiny moon where an entire ocean world exists just beneath our feet, metaphorically speaking. Then there's Iapetus, one of Saturn's most mysterious moons, often called the yin-yang moon because of its dramatic two-toned appearance. One hemisphere of Iapetus is as bright as fresh snow, while the other is as dark as charcoal. For centuries, this puzzled astronomers. When Giovanni Cassini first discovered Iapetus in 1671, he could only see it on one side of its orbit around Saturn. The moon seemed to appear and disappear, leading him to correctly deduce that one side must be much darker than the other. We now know that Iapetus's dark material likely comes from another of Saturn's moons, Phoebe, which orbits much farther out and in a retrograde direction. Over millions of years, dust from Phoebe has been swept up by Iapetus as it plows through its orbit, coating the leading hemisphere in dark material. But there's more to the story. The dark material absorbs more sunlight, causing ice to sublimate and migrate to the colder, brighter regions, which makes the bright areas even brighter and the dark areas even darker. It's a runaway process that has created one of the most striking visual contrasts in the solar system. Iapetus has another peculiar feature, a towering ridge that runs along much of its equator, giving the moon an appearance reminiscent of a walnut. This ridge rises up to 20 kilometers high in places, and its origin remains a mystery. Some scientists think it might be the remnant of a collapsed ring system, while others suggest it could be the result of ancient tidal forces when Iapetus was closer to Saturn and spinning much faster than it does today. Among Saturn's smaller moons, we find the shepherd moons, tiny worlds that play an outsized role in maintaining the structure of Saturn's rings. Prometheus and Pandora, for instance, work together to keep the F ring in line, their gravitational influence preventing the ring particles from spreading out into space. These moons are small and potato-shaped, but their gravitational shepherding is essential to the ring system's delicate architecture. Then there's Mimas, a moon that bears the scars of cosmic violence. Mimas is dominated by an enormous crater called Herschel, which spans about 1/3 of the moon's diameter. The impact that created this crater must have nearly shattered Mimas entirely. If the impactor had been much larger or hit with slightly more energy, Mimas might have been destroyed completely, adding its fragments to Saturn's rings. Instead, it survived, bearing this dramatic scar as a reminder of the chaotic early days of the solar system when impacts were far more common. Hyperion is another oddity, a sponge-like moon with an irregular, chaotic rotation. Unlike most moons, which keep one face pointed toward their planet due to tidal locking, Hyperion tumbles unpredictably as it orbits Saturn. Its surface is covered in deep craters that give it a porous, almost cellular appearance, as if someone had carved it from cosmic Swiss cheese. The low density of Hyperion suggests it's largely made of water ice with significant empty space, which might explain its unusual appearance and chaotic behavior. And then there are the Trojan moons, pairs of moons that share the same orbit around Saturn. Tethys shares its orbital path with two smaller moons, Telesto and Calypso, which sit at gravitationally stable points 60 degrees ahead and behind Tethys. Similarly, Dione has two co-orbital companions, Helene and Polydeuces. These arrangements are examples of what mathematicians call Lagrange points, special locations where the gravitational forces of Saturn and the larger moon combine to create stable parking spots for smaller objects. What makes Saturn's moon system particularly fascinating is how interconnected everything is. The moons influence each other through gravitational resonances, where their orbital periods are related by simple mathematical ratios. These resonances can either stabilize orbits or, in some cases, make them chaotic. The interplay between the moons and the rings creates a dynamic, ever-changing system where matter and energy flow between different components. Some of Saturn's moons are sources of ring material. When micrometeorites strike their surfaces, tiny particles are kicked up into space, some of which end up in Saturn's rings. Other moons act as sinks, sweeping up ring particles and gradually cleaning gaps in the ring system. It's a cosmic recycling program that has been operating for millions or perhaps billions of years. The diversity among Saturn's moons reflects the different ways that worlds can form and evolve. Some, like Titan and Enceladus, are large enough and in the right conditions to maintain active geology and complex chemistry. Others, like Mimas and Hyperion, bear the frozen scars of ancient impacts and have remained largely unchanged for eons. Some formed alongside Saturn from the original disk of material that surrounded the young planet, while others are likely captured objects that originated elsewhere in the solar system. Each moon is a world with its own story, its own mysteries, and its own beauty. From Titan's methane lakes to Enceladus's hidden ocean, from Iapetus's two-faced appearance to the shepherd moon's cosmic choreography, Saturn's satellites remind us that our solar system is filled with wonders beyond our everyday experience. They challenge our assumptions about what makes a world interesting or potentially habitable, showing us that life might find a way in the most unexpected places. As we continue to study these distant worlds through telescopes and spacecraft, we're not just learning about Saturn's moons. We're discovering the incredible diversity of planetary bodies that exist throughout the universe. Each new observation adds another piece to the puzzle of how solar systems form, evolve, and perhaps give rise to life. In the gentle dance of Saturn's moons, we see both the cosmic forces that shape worlds and the delicate beauty that emerges from billions of years of gravitational choreography. Now we enter the vast halls of Saturn's family, a diverse collection of moons that would make any planetary scientist weep with joy. Saturn doesn't just have rings, it has an entire retinue of natural satellites, each with its own personality, its own secrets, and its own contribution to the grand symphony we call the Saturnian system. From tiny shepherd moons that keep the rings in line to massive worlds with their own weather systems, Saturn's moons are a masterclass in cosmic diversity. At last count, Saturn has 146 confirmed moons, though that number keeps growing as our telescopes peer deeper into the system. Some are barely more than captured asteroids, irregularly shaped chunks of rock and ice tumbling through space. Others are proper spherical worlds, large enough that their own gravity has pulled them into neat, round shapes. And a few are so extraordinary they've rewritten our understanding of what a moon can be. Let's begin with the grand dame of Saturn's moons, Titan. If Saturn is the jewel of the outer solar system, then Titan is its crown jewel. Larger than Mercury, Titan is the second largest moon in the entire solar system, and it's the only moon known to have a substantial atmosphere. Not just wisps of gas, mind you, but a thick, dense atmosphere that's actually denser than Earth's. When you look at Titan through a telescope, you don't see its surface at all. Just a hazy, orange-brown shroud that completely obscures the world beneath. That atmosphere is primarily nitrogen, just like Earth's, but with a crucial difference. Instead of oxygen, Titan's air is laced with methane and other hydrocarbons. This creates a greenhouse effect that keeps the surface surprisingly warm for a world so far from the sun. Though warm is relative. We're talking about minus 179 degrees Celsius. Still, that's warm enough for something extraordinary to happen. You see, on Titan, methane plays the role that water plays on Earth. There are methane clouds in the sky, methane rain falling from those clouds, and methane rivers carving channels across the landscape. There are methane lakes, vast, dark bodies of liquid hydrocarbon nestled in impact craters and tectonic basins. The largest of these, Kraken Mare, is bigger than the Caspian Sea. Imagine sailing across a lake of liquid natural gas under an orange sky, with hydrocarbon rain pattering against your spacecraft's hull. It's alien, yet strangely familiar. The Cassini mission gave us our most detailed look at this remarkable world. Using radar to peer through Titan's thick atmosphere, Cassini mapped mountains, valleys, dunes, and those famous methane seas. It even dropped a probe called Huygens onto Titan's surface in 2005, the first and only landing in the outer solar system. Huygens sent back images of a landscape that looked almost Earth-like. Rounded rocks, carved by flowing liquid, sitting beneath a butterscotch sky. But Titan's wonders don't end with its methane cycle. Deep beneath its icy crust, Titan likely harbors an ocean of liquid water, a hidden sea that might contain more water than all of Earth's oceans combined. This subsurface ocean, warmed by tidal heating from Saturn's gravity, raises tantalizing questions about the possibility of life. Could something be swimming in those dark waters, far from the sun's light? Then there's Enceladus, Saturn's sixth largest moon, and perhaps the most exciting destination in the solar system for astrobiologists. Enceladus is small, only about 500 kilometers across, and it looks like a perfect white marble, its surface covered in pristine ice that reflects sunlight like a cosmic mirror. But this serene appearance is deceiving. In 2005, Cassini made a discovery that stunned the scientific world. Enceladus has geysers. From its south polar region, massive plumes of water vapor and ice particles shoot hundreds of kilometers into space. These aren't gentle puffs of steam. They're powerful jets erupting from long fractures in the ice, nicknamed tiger stripes for their distinctive appearance. The geysers are so vigorous that much of the material escapes Enceladus entirely, spreading out to form Saturn's E-ring. What powers these geysers? The answer lies beneath Enceladus's icy shell. Like Titan, this small moon harbors a global ocean of liquid water, kept warm by tidal heating as Saturn's gravity stretches and squeezes the moon during its elliptical orbit. But unlike Titan's buried ocean, Enceladus's water is in direct contact with the surface through cracks in the ice. When Cassini flew through the geyser plumes, it detected not just water vapor, but also organic compounds, the building blocks of life as we know it. The implications are staggering. Here's a moon with liquid water, organic chemistry, and an energy source, all the ingredients thought necessary for life. Scientists now consider Enceladus one of the most promising places in the solar system to look for extraterrestrial life, and future missions are being planned to sample those geysers more thoroughly. Moving outward from Saturn, we encounter Iapetus, a moon so strange it seems designed to puzzle astronomers. Iapetus has a two-toned appearance. One hemisphere is as dark as charcoal, while the other is as bright as fresh snow. The dark material, called Cassini regia, after the astronomer who first noticed Iapetus's brightness variations, covers the leading hemisphere like cosmic road tar. The bright material dominates the trailing hemisphere, creating a moon that looks like a yin-yang symbol when viewed from certain angles. How did Iapetus acquire this bizarre coloration? The leading theory involves dust from Saturn's outer moons. As Iapetus orbits, its leading hemisphere sweeps up dark particles, probably knocked off other moons by micrometeorite impacts. This dark material absorbs sunlight and warms up, causing nearby ice to sublimate away and exposing even more dark material underneath. Meanwhile, the trailing hemisphere remains pristine and reflective. It's a slow process, but over billions of years, it's created one of the most distinctive-looking objects in the solar system. But Iapetus has another peculiarity: a massive ridge that runs almost exactly along its equator, giving the moon the appearance of a walnut. This ridge, which rises up to 20 kilometers above the surrounding terrain, is unique in the solar system. No one knows exactly how it formed, though theories range from the remnants of a collapsed ring system to the result of ancient tidal forces when Iapetus was much closer to Saturn. Then there's Mimas, a small moon with a big personality, or at least a big crater. Mimas is famous for its resemblance to the Death Star from Star Wars, thanks to a massive impact crater called Herschel that dominates one hemisphere. This crater is about 130 kilometers across on a moon that's only 396 kilometers in diameter. Proportionally, it's like having a crater the size of Australia on Earth. The impact that created Herschel must have nearly shattered Mimas entirely. In fact, there are fractures on the opposite side of the moon that might be related to shock waves from this ancient collision. Despite its small size, Mimas plays an important role in Saturn's system. It's responsible for the Cassini division, the most prominent gap in Saturn's rings. Through a process called orbital resonance, Mimas's gravity tugs on ring particles in just the right way to clear out a specific region, creating the dark gap that divides the A and B rings. Hyperion is Saturn's chaos moon, a tumbling, sponge-like world that refuses to rotate in any predictable pattern. Unlike most moons, which are tidally locked to their parent planet, Hyperion spins chaotically, tumbling end over end in an unpredictable dance. Its surface is covered in deep craters that give it a honeycomb appearance, as if it's made of cosmic Swiss cheese. This peculiar texture might result from the moon's low density and porous structure. Hyperion seems to be more empty space than solid material. Each of these moons tells part of Saturn's story. Some, like Titan and Enceladus, might harbor the ingredients for life. Others, like Iapetus and Mimas, bear the scars of ancient impacts and cosmic processes. Together, they form a family of worlds as diverse as any in the solar system, each one a chapter in the longer tale of how planetary systems form and evolve. The gravitational relationships between these moons are just as fascinating as the moons themselves. Many of Saturn's satellites are locked in orbital resonances, mathematical relationships where their orbital periods are simple ratios of each other. Titan and Hyperion, for example, are in a 4.3 resonance, meaning Titan completes 4 orbits for every 3 of Hyperion's. These resonances help stabilize the system over long periods, preventing close encounters that might disrupt the delicate balance. But perhaps most remarkably, Saturn's moons don't just orbit in isolation. They actively shape and maintain the very rings that make Saturn famous. Small shepherd moons like Prometheus and Pandora patrol the edges of the F-ring, their gravity corralling wayward particles and maintaining the ring's sharp boundaries. Other moons create gaps, waves, and spokes in the rings through their gravitational influence. It's a dynamic, ever-changing system where rings and moons work together in an intricate gravitational ballet. As we drift further from Saturn's warm embrace, we encounter the irregular moons, small, distant worlds with tilted, elongated orbits that suggest they're captured asteroids or comets. These outer moons, with names like Phoebe and Ymir, orbit Saturn backwards or at extreme angles, testament to their violent capture from the outer reaches of the solar system. They're time capsules from the early solar system, preserving conditions from billions of years ago. The story of Saturn's moons is still being written. Future missions may return to Titan to explore its methane lakes, or dive through Enceladus's geysers to sample its hidden ocean directly. Each new discovery adds another verse to Saturn's symphony, another layer to our understanding of this magnificent system. From the hydrocarbon seas of Titan to the water geysers of Enceladus, from the two-faced mystery of Iapetus to the Death Star visage of Mimas, Saturn's moons remind us that our solar system is filled with worlds as strange and wonderful as any science fiction could imagine. And perhaps that's the most beautiful part of Saturn's story. It's not just about rings and storms and distant beauty. It's about possibility, about the countless ways that gravity and chemistry and time can conspire to create something extraordinary. As we drift further into the depths of Saturn's cosmic neighborhood, we find ourselves drawn to the planet's most magnificent feature, those ethereal rings that have captivated human imagination for centuries. What we once thought were solid bands encircling the planet are actually something far more delicate and extraordinary. Countless billions of ice particles, each no larger than a house, some as small as grains of sand, all dancing in perfect orbital harmony around their giant host. These rings aren't the solid, unchanging structures they appear to be from Earth. They're dynamic, shifting, breathing almost. A cosmic ballet performed by fragments of water ice mixed with traces of rocky debris. The rings extend outward from Saturn for tens of thousands of kilometers, yet they're surprisingly thin, often no thicker than a few hundred meters. If you could shrink Saturn's rings down to the size of a piece of paper, they would be thinner than tissue, more gossamer than substance, held together not by physical connection, but by the invisible threads of gravity and orbital mechanics. The major ring divisions we can see: the A ring, the B ring, the C ring, and the fainter D and E rings, each tell their own story. The B ring, the brightest and most massive, contains most of the ring material, while the A ring sits farther out, separated from the B ring by the famous Cassini division, a gap wide enough to fit the entire planet Mercury. This gap isn't empty space, mind you, but rather a region where the gravitational influence of Saturn's moon Mimas creates a resonance that sweeps particles away, like a cosmic street sweeper working in slow motion. What's particularly fascinating is how temporary these rings might be. Despite their ancient appearance, scientists now believe Saturn's rings could be relatively young in cosmic terms, perhaps only a few 100 million years old, formed when a moon or large comet wandered too close to Saturn and was torn apart by tidal forces. The ice particles we see today might be the scattered remains of that long-lost celestial body, slowly spiraling inward toward Saturn as they lose energy through countless tiny collisions. But Saturn's story extends far beyond its rings. The planet itself is a marvel of atmospheric dynamics, with winds that can reach speeds of over 1,800 kilometers per hour, nearly 5 times faster than the strongest hurricanes on Earth. These winds are driven by heat rising from Saturn's interior, where the planet radiates more energy than it receives from the sun. Deep within Saturn's core, hydrogen is compressed so intensely that it becomes metallic, conducting electricity and generating the planet's powerful magnetic field. Perhaps most mysteriously, Saturn sports a perfectly hexagonal cloud formation at its north pole, a 6-sided weather pattern larger than Earth itself. This geometric storm has persisted for decades, its rigid angles defying our understanding of how fluid dynamics should work in a rotating atmosphere. It's as if Saturn decided to doodle in its own clouds, creating patterns that seem more at home in a geometry textbook than in the swirling chaos of a gas giant's atmosphere. The planet's magnetic field, while not as strong as Jupiter's, creates its own aurora displays and generates radio emissions that sound eerily like voices when converted to audio. Saturn literally sings to itself in radio waves, a cosmic choir that NASA's Cassini spacecraft recorded during its 13-year mission studying the system. And then there are Saturn's moons, over 80 known satellites, each with its own personality and secrets. Titan, larger than Mercury, shrouded in a thick orange atmosphere of nitrogen and methane, harbors lakes and rivers of liquid hydrocarbons on its surface, while hiding a subsurface ocean that might contain more water than all of Earth's oceans combined. It's a world where methane rain falls from hydrocarbon clouds, where the familiar water cycle of Earth is replaced by an alien chemistry that still manages to create weather, erosion, and perhaps even the conditions for life. Enceladus, smaller and icier, surprised everyone when Cassini discovered geysers of water vapor erupting from its south pole. These aren't simple geysers. They're windows into a subsurface ocean, kept liquid by tidal heating from Saturn's gravity. The water contains organic compounds, the basic ingredients for life as we know it, making this small, frozen world one of the most promising places to search for extraterrestrial life in our solar system. There's Iapetus, with its mysterious two-tone coloration, one hemisphere bright as fresh snow, the other dark as charcoal, and an enormous ridge running along its equator like a cosmic seam. There's Mimas, cratered and battered, with one impact so large it nearly shattered the moon entirely, leaving behind a crater that makes the moon look remarkably like the Death Star from Star Wars. There's Hyperion, tumbling chaotically through space, its sponge-like surface pocked with deep craters that trap sunlight and create one of the darkest surfaces in the solar system. Each of these moons interacts with Saturn's rings in subtle ways. Some, called shepherd moons, actually help maintain the ring structure by gravitationally herding particles into narrow bands. Others, like Prometheus and Pandora, create waves and gaps in the rings through their gravitational influence. Their orbital dance with ring particles, creating patterns that ripple outward like the wake of a boat on a cosmic pond. The more we study Saturn's system, the more we realize how interconnected everything is. The rings influence the moons. The moons shape the rings. Saturn's magnetic field interacts with both, and all of it is constantly evolving, changing on timescales from minutes to millions of years. It's a living system, a gravitational ecosystem, where every component affects every other component in ways we're still discovering. What makes Saturn's story even more remarkable is how much of it has been revealed only recently. When Galileo first pointed his primitive telescope at Saturn in 1610, he saw what he described as a planet with handles or ears. His telescope wasn't powerful enough to resolve the rings clearly. It wasn't until 1659 that Christian Huygens correctly identified them as rings, and not until the Voyager flybys in the 1980s that we began to understand their true complexity. The Cassini mission, which ended in 2017 with a planned dive into Saturn's atmosphere, revolutionized our understanding of this distant world. For 13 years, this robotic explorer sent back images and data that transformed Saturn from a distant, mysterious planet into a complex, dynamic world filled with wonders that continue to challenge our understanding of how planetary systems work. As we contemplate Saturn's majesty from our quiet corner of the cosmos, we're reminded that the universe is far stranger and more beautiful than we ever imagined. Here is a world where rings of ice dance in perfect formation, where moons harbor hidden oceans, where hexagonal storms rage in alien skies, and where the gentle gravitational whispers between distant objects create symphonies of motion that have been playing for billions of years. Saturn teaches us that even in the cold vacuum of space, beauty emerges from the simple laws of physics: gravity, motion, thermodynamics, combining in ways that create complexity, elegance, and wonder. It reminds us that our solar system is not just a collection of rocks and gas balls orbiting the sun, but a dynamic, interconnected web of worlds, each with its own story, its own mysteries, its own quiet majesty spinning through the darkness. So as you drift towards sleep tonight, perhaps you'll dream of sailing through Saturn's rings, of walking on the methane shores of Titan's lakes, of witnessing the ice geysers of Enceladus painting brief arcs against the star-filled sky. As Saturn's story unfolds before us like a cosmic symphony, we arrive at a chapter both beautiful and heartbreaking: the death of worlds. Tonight, we drift through the final movements of Saturn's celestial dance, where moons may vanish, rings will fade, and even mighty planets must eventually bow to the relentless passage of time. Picture Saturn as it exists today, adorned with its magnificent rings, attended by dozens of loyal moons, spinning gracefully in the outer reaches of our solar system. It seems eternal, doesn't it? A fixture in our night sky, a constant in the cosmic order. But like all things in the universe, Saturn's current splendor is temporary, a fleeting moment in a story that spans billions of years. The rings, those gossamer bands that make Saturn the jewel of our solar system, are already dying. They're not the ancient relics we once thought them to be. Recent discoveries from the Cassini mission revealed that Saturn's rings are surprisingly young, perhaps only 100 to 400 million years old. In cosmic terms, that's practically yesterday. The dinosaurs roamed Earth for longer than Saturn has worn its current crown of ice and rock, and these rings are not stable. They're constantly losing material, raining down onto Saturn's atmosphere at a rate that would fill an Olympic swimming pool every half hour. The process is gentle, almost poetic in its inevitability. Tiny particles, pulled by Saturn's gravity and influenced by its magnetic field, spiral slowly inward. The planet literally consumes its own ornaments, like a cosmic Ouroboros adorned with diamonds. At this rate, Saturn's rings will be gone in perhaps 300 million years. Future civilizations, if any exist to witness it, will look up at Saturn and see only a pale yellow dot, stripped of the glory that once defined it. The ring system that has inspired countless poets, artists, and dreamers will exist only in the fossil record of light, ancient photons carrying the memory of beauty across the void. But the rings are not alone in their mortality. Saturn's moons, too, face uncertain futures. Some will be consumed by their parent planet. Others will drift away into the lonely darkness of space. Enceladus, with its magnificent geysers and subsurface ocean, may one day fall silent as its internal heat dissipates and its geological activity ceases. The fountains of water that currently shoot hundreds of kilometers into space will weaken, sputter, and finally stop, leaving behind a frozen, dormant world. Titan, Saturn's largest moon and perhaps the most Earth-like world in our solar system, faces its own eventual demise. Its thick atmosphere, fed by methane from its interior, will slowly leak away into space. The hydrocarbon cycle that creates its lakes and rivers will wind down as the moon's internal processes slow. The orange haze that currently shrouds this fascinating world will thin and dissipate, revealing a surface that will grow increasingly cold and barren. The smaller moons, those irregularly shaped chunks of rock and ice that tumble in chaotic orbits, will eventually be scattered by gravitational perturbations. Some will crash into Saturn or its larger moons, while others will be flung into interplanetary space, becoming lonely wanderers in the cosmic dark. The complex gravitational ballet that currently maintains the delicate architecture of Saturn's moon system will slowly unravel as tidal forces and orbital mechanics take their inexorable toll. Even the shepherd moons that help maintain the ring structure will eventually lose their battle against entropy. These small worlds, whose gravitational influence keeps certain ring particles in line, will either be consumed by Saturn or drift away from their posts. Without their guiding presence, the rings will lose even more cohesion, accelerating their already inevitable decay. Saturn itself, while more enduring than its ornaments, is not immortal. The planet's internal heat, generated by the slow gravitational compression that has warmed it for billions of years, will gradually dissipate. Saturn currently radiates more energy than it receives from the Sun, but this will not last forever. As the planet cools, its weather patterns will change. The hexagonal storm at its North Pole, that geometric marvel that has fascinated scientists, may weaken and eventually disappear. The bands of clouds that give Saturn its subtle beauty will fade as atmospheric dynamics slow. The planet's magnetic field, generated by the movement of metallic hydrogen in its core, will weaken as internal processes slow down. This magnetic field, which currently protects Saturn's moons and shapes its magnetosphere, will no longer provide the same shelter. Without this protection, solar wind will more easily strip away atmospheric material from Saturn's moons, accelerating their transformation into lifeless, airless rocks. But we must zoom out further to see the ultimate fate that awaits Saturn. Our Sun, the source of all energy in our solar system, is slowly brightening as it ages. Over the next billion years, it will become hot enough to boil Earth's oceans and strip away our planet's atmosphere. For Saturn, so much farther from the Sun, this increased solar output will initially be beneficial. The ice on Saturn's moons will begin to melt, potentially creating temporary oceans on worlds that are currently frozen solid. Imagine a future where Enceladus's subsurface ocean breaks through to the surface, creating a water world in the outer solar system. Or picture Titan, its methane lakes evaporated, revealing a landscape of organic compounds baked by a sun now bright enough to drive chemistry that was previously impossible at such distances from our star. But this renaissance will be brief. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core and begin its transformation into a red giant. It will swell to enormous proportions, possibly large enough to engulf the inner planets. Even if Saturn escapes direct consumption, the dying sun will blast the outer solar system with intense radiation and stellar winds. Saturn's remaining moons will be stripped of any atmospheres they might have developed during the sun's brightening phase. The increased solar wind will blow away the last vestiges of Saturn's magnetosphere, leaving the planet and its satellites exposed to the harsh environment of interstellar space. Any water that had melted during the sun's bright phase will freeze again, harder and more permanently than before. Eventually, the sun will shed its outer layers, creating a beautiful but deadly planetary nebula with a white dwarf star at its center. This white dwarf will be incredibly hot initially, but will provide little energy to the outer planets. Saturn, if it survives the red giant phase, will find itself orbiting a fading ember in a solar system transformed beyond recognition. The planet will enter a long, cold period of slow decay. Without the sun's energy to drive atmospheric circulation, Saturn's weather will gradually cease. The beautiful bands of clouds will settle into uniform, frozen layers. The planet's rotation will slow due to tidal forces, though this process will take an almost unimaginably long time. Over trillions of years, Saturn will cool to the point where even its hydrogen and helium atmosphere begins to condense. The planet will shrink as its gases turn to liquid, and eventually to exotic forms of solid matter under the immense pressure. What was once a majestic gas giant will become a strange, dense world composed of materials that don't exist anywhere on Earth. But even this is not the end of Saturn's story. Over timescales that dwarf the current age of the universe, the very protons that make up Saturn's atoms may decay, causing the planet to slowly evaporate into space. 8 billion years since the Big Bang seem like the blink of an eye. Alternatively, Saturn might eventually be consumed by a black hole, either one wandering through space or perhaps the black hole that some theories suggest our Sun might become through quantum processes over unimaginably long timescales. In this scenario, Saturn would be stretched apart by tidal forces as it approaches the event horizon, its material scattered across space in long, glowing streams before finally disappearing beyond the point of no return. Yet perhaps the most poetic end for Saturn would be a close encounter with another star system. As our Sun's remnant wanders through the galaxy over billions of years, it might pass close enough to another star to gravitationally disrupt the orbits of the remaining planets. Saturn could be flung from the solar system entirely, becoming a rogue planet wandering the galaxy alone. Picture Saturn, stripped of its rings and moons, drifting silently through interstellar space. It would be invisible against the cosmic background, detectable only by its gravitational influence on nearby objects. This lonely wanderer would carry within it the compressed history of our solar system, a fossil record of the time when stars were young and planets wore crowns of ice. But in contemplating these far future scenarios, we must remember that endings are also beginnings. The material that makes up Saturn, forged in the hearts of ancient stars and assembled over billions of years, will not simply disappear. Even as Saturn itself may fade, its atoms will eventually become part of new worlds, new stories, new possibilities. The carbon in Titan's organic compounds might one day form the backbone of life on some distant world. The water from Enceladus's geysers could become the oceans of future planets. The hydrogen and helium that make up Saturn's bulk might fuel new stars, providing the energy for civilizations we cannot imagine. In this sense, Saturn's death is not an ending, but a transformation. The planet that has graced our night sky and captured our imagination is temporary, but the matter and energy that compose it are eternal, constantly recycled through the cosmic ecosystem. Saturn is not just witnessing the universe's story, it is part of that story, a chapter in the grand narrative of matter and energy that began with the Big Bang and will continue long after our sun has faded to a cold, dark ember. As we drift toward sleep tonight, perhaps we can find comfort in this cosmic perspective. Yes, Saturn's rings will fade, its moons will fall silent, and the planet itself will eventually succumb to the passage of time. But the beauty we see today, the wonder that fills us when we contemplate this distant world, is real and present. We are witnessing Saturn in its glory days, adorned with rings, attended by fascinating moons, still warm from its formation billions of years ago. And in some strange way, by observing Saturn, by studying its moons and rings, by sending spacecraft to explore its mysteries, we are participating in the planet's story. Human consciousness has become part of Saturn's narrative, adding meaning and appreciation to its cosmic dance. Through our eyes, Saturn not only exists, but is celebrated, understood, and loved. The universe may be vast and ultimately temporary, but it has given rise to minds capable of contemplating its beauty and finding meaning in its patterns. Saturn's eventual fate reminds us that everything we cherish is precious precisely because it is fleeting. The rings that will fade in 300 million years are glorious today. The moons that will one day fall silent are active and fascinating now. The planet that will eventually cool and fade is magnificent in this moment. So as you close your eyes tonight, carry with you the image of Saturn as it exists now. A golden world wreathed in silver rings, accompanied by moons of ice and organic mystery, spinning serenely in the outer darkness of our solar system. It is a vision of beauty that will endure in human memory long after the rings have fallen and the moons have gone silent. And perhaps, in some distant future, when new worlds have formed from Saturn's scattered atoms and new minds have evolved to contemplate the cosmos, they too will look up at their night sky and find wonder in the dance of planets and moons. They may not know of Saturn, may not remember the ringed world that once graced our solar system, but they will carry forward the eternal human capacity for awe, the same sense of wonder that connects us to the cosmos and makes us part of its ongoing story. You've emerged from the cosmic darkness, drifted through the formation of the first stars, and witnessed the grand architecture of galactic birth. Now, as we continue our gentle voyage through Saturn's realm, let's turn our attention to something equally mysterious, yet far more intimate. The curious relationship between time and dreams in the depths of space. Picture this. You're an astronaut aboard a space station, orbiting high above Earth every 90 minutes. The sun rises and sets 16 times in what we call a single day. Your circadian rhythms, those ancient biological clocks we discussed earlier, are suddenly cast adrift in an ocean of artificial light and endless twilight. How do you dream when day and night have lost all meaning? How does your mind measure time when time itself seems to float weightlessly around you? This isn't just a thought experiment. Real astronauts have reported the strangest dreams during long missions. Some dream of falling not toward Earth, but away from it, drifting endlessly into the void. Others find their dreams populated by the rhythmic hum of life support systems, the gentle whoosh of recycled air becoming the soundtrack to their subconscious wanderings. And perhaps most curious of all, many report that their dreams feel longer, more vivid, as if the absence of gravity has somehow freed their minds to explore landscapes that defy not just physics, but logic itself. You see, when we remove the familiar anchors of day and night, when we lift ourselves beyond the gentle tug of Earth's gravity, something fascinating happens to human consciousness. Time begins to behave differently, not just in the equations of relativity we explored in our cosmic journey, but in the lived experience of dreaming minds. Sleep cycles stretch and compress like cosmic phenomena, and dreams become the only reliable compass in a world where up and down have lost their meaning. Consider the profound loneliness of space travel, that vast silence broken only by the mechanical whispers of technology keeping you alive. In such isolation, dreams become more than mere neural housekeeping. They become companions, visitors from a world that suddenly feels impossibly distant. Astronauts have described dreaming of Earth not as a planet, but as a feeling. The weight of rain, the resistance of wind against their face, the simple joy of dropping something and watching it fall predictably downward. But there's something even more intriguing happening in these orbital dreams. Without the Earth's magnetic field to fully shield them, space travelers are exposed to cosmic radiation, those ancient particles that have traveled across the universe for millions of years before finally encountering a human brain. Some researchers wonder whether this cosmic bombardment might influence the dreaming mind in ways we're only beginning to understand. Could dreams in space carry whispers of the cosmos itself? Are we, in our sleeping moments beyond Earth's atmosphere, somehow more connected to the vast universe that birthed us? The mathematics of sleep in space are equally fascinating. REM cycles, those periods of rapid eye movement where our most vivid dreams unfold, seem to respond to the absence of gravity in unexpected ways. The brain, no longer needing to constantly calibrate balance and orientation, redirects its energy toward other processes. Some astronauts report dreams of such clarity and emotional intensity that they wake wondering whether they've experienced something more than mere neural firing, something closer to revelation. And then there's the question of memory formation in the weightless environment of space. We know that dreams play a crucial role in consolidating memories, in filing away the experiences of the day into long-term storage. But what happens when the experiences themselves are so far outside the normal range of human existence? How does a dreaming mind process the sight of Earth hanging like a blue marble in infinite darkness? How do you dream about something for which evolution has provided no reference point? Perhaps most beautifully, astronauts often report dreams of flying that feel different from the typical flying dreams we earthbound dreamers experience. Instead of the usual sensation of moving through air, these space dreams involve a kind of liquid motion, a graceful drift through dimensions that seem to bend and fold, like the fabric of space-time itself. It's as if, freed from gravity's constraints, the dreaming mind finally remembers what it might feel like to truly soar. There's a poetic symmetry here. As we've learned, we are all made of star stuff, forged in the nuclear furnaces of ancient suns and scattered across the cosmos by stellar winds and supernova explosions. When we dream in space, perhaps we're not just processing the day's experiences. Perhaps we're participating in a kind of cosmic memory, a neural echo of our deepest origins among the stars. The silence of space, that profound quiet that can never be truly experienced on Earth, seems to amplify the inner voice of dreams. Without the constant background noise of atmosphere, weather, and terrestrial life, the dreaming mind appears to turn inward with unusual intensity. Some astronauts describe dreams so vivid they seem more real than waking life, filled with colors that don't exist in Earth's spectrum and sounds that seem to come from within the fabric of space itself. And what of the dreams of future space travelers, those who might one day journey to Mars or beyond? Will their dreams adapt to the longer days and nights of alien worlds? Will they dream of home with increasing abstraction as Earth dwindles to a point of light among countless others? Or will they dream forward toward destinations not yet imagined, their sleeping minds serving as scouts for consciousness itself, venturing into the unknown? These questions remind us that dreaming is not just a biological process, but a fundamentally human one. It's how we make sense of experiences that exceed our understanding, how we integrate the impossible into the fabric of memory and meaning. In space, dreams become a bridge between the familiar and the infinite, between the small scale of human consciousness and the vast scale of cosmic existence. So as you drift towards sleep tonight, here in the comfort of Earth's embrace, remember that somewhere above you, fellow humans are dreaming dreams unlike any in the history of our species. They're floating in metal cocoons, surrounded by the infinite, their minds wandering through landscapes that exist nowhere else in the universe. Their dreams are humanity's dreams, carried beyond the boundaries of our pale blue dot into the cosmic dark. As we've journeyed through Saturn's magnificent realm, exploring its ancient rings, diverse moons, and dynamic systems, we've witnessed a cosmic dance that has unfolded for billions of years. But what happens when we step back and consider Saturn not just as it is today, but as part of an even grander story? What happens when we imagine ourselves among the stars, dreaming in the vast emptiness of space itself? Picture this. You're an astronaut, floating in a small capsule somewhere between Saturn's rings and Titan's methane lakes. The familiar pull of Earth's gravity is a distant memory, replaced by the gentle drift of microgravity. Your body floats weightless, tethered only by the soft restraints of your sleeping harness. Outside your small window, Saturn hangs like a jewel against the star-scattered darkness, its rings catching and scattering sunlight in ways that no earthbound observer could ever imagine. And then, as your eyes grow heavy and your breathing slows, you begin to dream. Dreaming in space, it turns out, is a peculiar thing. Astronauts who have spent months aboard the International Space Station report dreams unlike anything they experience on Earth. Without the constant downward pull of gravity, the brain's spatial orientation systems, the inner ear's vestibular organs, the proprioceptors in muscles and joints, send different signals during sleep. Dreams of flying, which on Earth might feel magical and impossible, become mundane recollections of daily life. Dreams of falling, those jarring moments that usually wake us with a start, simply don't occur when down has no meaning. Instead, space dreams often focus on different sensations entirely. The sound of air recyclers humming becomes the rhythm of alien winds. The sight of Earth, that pale blue dot suspended in infinite darkness, transforms in dreams into vast oceans where continents drift like islands in space. Some astronauts report dreaming in slow motion, as if their subconscious minds are trying to process the surreal experience of existing in an environment where human beings were never meant to be. But what would it be like to dream while floating among Saturn's rings? To close your eyes with the shepherd moons Prometheus and Pandora visible through your viewport, watching their eternal dance as they sculpt the F-ring's braided structure. Your sleeping mind might weave together the sight of countless ice particles, some no larger than grains of sand, others as big as houses, into dreams of snow that falls upward, or crystal cathedrals that sing with the music of gravitational resonances. Perhaps you dream of surfing through the Cassini division, that dark gap between the A and B rings, riding waves of gravitational influence that ripple outward from Mimas in its distant orbit. In your dream, the ring particles might become a vast field of diamonds, each one catching Saturn's pale light and throwing it back in rainbow cascades. You might find yourself swimming through this cosmic jewelry box, your dream self moving with the fluid grace that only comes when the laws of physics bend to the imagination's will. Or maybe your dreams would carry you down to Titan's surface, that strange world of methane rain and hydrocarbon lakes. In the reduced gravity, about 1/7 of Earth's, your dream self might bound across landscapes of orange-tinted ice, watching geysers of liquid methane arc impossibly high into the thick, hazy atmosphere. The familiar becomes alien, rain that isn't water, rocks that are made of ice harder than steel, an atmosphere so dense you could strap wings to your arms and fly like a bird through Titan's eternal twilight. These aren't just flights of fancy. The connection between our environment and our dreams is real and measurable. Studies of people living in extreme environments, Antarctic research stations, deep-sea habitats, isolated mountain outposts, show that our surroundings profoundly influence the content and character of our dreams. The brain, it seems, uses sleep not just to process the day's experiences, but to integrate them with our deepest sense of place and belonging. In space, far from Earth's familiar blue skies and green landscapes, dreams often become more vivid, more emotionally intense. Some astronauts report dreaming repeatedly of Earth, not as the abstract globe we see in photographs, but as a living, breathing presence they can feel pulling at them across the vacuum. Others dream of their families with an immediacy and clarity that sometimes feels more real than waking communication through crackling radio links. But there's another dimension to dreaming in Saturn's realm, one that touches on something even more profound than the mechanics of sleep in microgravity. To float among those ancient rings, to witness the slow orbital ballet of dozens of moons, is to confront directly the vast scales of cosmic time and space that usually exist only as numbers in textbooks. Saturn's rings, for all their beauty, are temporary. The same gravitational forces that maintain their structure are also slowly but inexorably pulling them apart. In perhaps 100 million years, a cosmic blink of an eye, the rings will have spiraled down into Saturn's atmosphere, their water ice particles adding to the planet's already substantial girth. The intricate patterns we see today, the gaps and divisions and braided F-ring, will be gone, leaving behind only the memory of their brief moment of glory. This knowledge might seep into the dreams of our hypothetical space-sleeping explorer. dreams of impermanence, of beauty that exists precisely because it cannot last forever. Dreams where the rings slowly fade away like melting snow, where the shepherd moons continue their faithful orbits long after the particles they once guided have vanished into Saturn's depths. Such dreams might carry a strange comfort. After all, Earth itself is temporary. Our sun will eventually exhaust its nuclear fuel, first swelling into a red giant that will likely engulf our home planet, then collapsing into a white dwarf star that will slowly cool over trillions of years. The Milky Way galaxy will collide with Andromeda in about 4 billion years, scrambling the stellar neighborhoods we know today. Even the protons that make up our bodies may eventually decay, given enough time, though that process would take longer than the current age of the universe multiplied by itself countless times over. But perhaps the most profound dreams would be those that connect the dreamer to the vast web of relationships that bind Saturn's system together. Every moon influences every other moon through gravity's invisible threads. Every ring particle responds to the gravitational pull of not just Saturn, but of every moon, every other particle, in an intricate dance of mutual influence that has been playing out for billions of years. In dreams, this web of connection might become visible, like golden threads stretching through space, connecting ice particle to shepherd moon to major satellite to Saturn itself. The dreamer might see themselves as part of this web, not separate from it, observing from outside, but woven into its very fabric. After all, the calcium in their bones was forged in ancient supernovas, the iron in their blood created in stellar cores, the water in their cells possibly delivered to early Earth by comets, not unlike those that contributed to Saturn's rings. These space dreams might blur the boundaries between self and cosmos in ways that earthbound sleep rarely allows. Floating weightless among Saturn's wonders, the dreaming mind might finally grasp, in a way that transcends mere intellectual understanding, what it truly means to be made of star stuff. To be temporary arrangements of atoms that have been cycling through the cosmos for billions of years, briefly organized into consciousness and wonder, destined to return to the cosmic dance when our personal stories end. Such dreams might be both humbling and exhilarating. Humbling because they reveal our tiny place in the vast cosmic order. We are less than specks in the immensity of space and time. But exhilarating because they also reveal our profound connection to everything else. We are not separate from the universe, but expressions of it. Ways the cosmos has evolved to understand itself. As our dreaming astronaut floats in their small capsule, Saturn's light filtering through their closed eyelids, their dreams might carry them even further, beyond the solar system, beyond the Milky Way, into the deep future when the last stars have burned out and the universe has grown cold and dark. In these dreams of ultimate endings, they might find strange peace. Because even in that far future, the atoms that once made up their body, the energy that once powered their thoughts, will still be there, still part of the eternal cosmic dance, still connected to everything that was and is and ever shall be. These are the dreams that only come to those who have ventured far enough from home to see it clearly, who have traveled deep enough into the cosmic dark to understand both how alone we are and how connected we are. Dreams that remind us that Saturn's rings, Titan's methane lakes, Enceladus's water geysers, and Earth's blue oceans are all part of the same magnificent, temporary, eternally changing story. And when our dreaming astronaut finally wakes, floating in their small capsule with Saturn's rings stretched across their window like a cosmic smile, they might carry with them the memory of those dreams, dreams that blur the line between sleeping and waking, between self and cosmos, between the temporary and the eternal. Dreams that remind us that in contemplating Saturn's realm, we are not just learning about a distant planet and its moons. We are learning about ourselves, about our place in the cosmic order, about the profound mystery of consciousness arising from star stuff to contemplate its own origins. The rings continue their ancient dance. The moons follow their orbital paths, and the cosmic story unfolds, as it has for billions of years, as it will for billions more. As we drift deeper into Saturn's gravitational embrace, our minds themselves become cosmic travelers, riding the gentle currents of sleep toward shores we've never seen. There's something profoundly beautiful about dreaming while contemplating the rings of Saturn, as if our sleeping consciousness somehow mirrors the vast, mysterious dance of ice and rock circling that distant world. Dreams, you see, are not confined to Earth. They ripple outward through the cosmos, carried by the same forces that shape Saturn's moons and sculpt its ethereal rings. When astronauts sleep aboard the International Space Station, floating weightless in their tethered sleeping bags, their dreams take on qualities unlike anything experienced on solid ground. Without the familiar tug of gravity, without the reassuring weight of blankets or the soft pressure of a pillow, the dreaming mind finds itself in a realm that mirrors the weightless ballet of Saturn's countless moonlets. Commander Chris Hadfield once described how dreams in space felt more fluid, more three-dimensional, as if consciousness itself had learned to float. In these orbital dreams, up and down lose their meaning, just as they do in the vast emptiness between Saturn's rings. The brain, freed from its earthbound expectations, begins to dream in new geometries, new possibilities. Astronauts report dreams of swimming through starlight, of conversations with planets, of riding cosmic winds that carry them through gaps in Saturn's rings. But the connection between dreams and space runs deeper than mere metaphor. When we sleep, our brains engage in a process remarkably similar to what happens in the vast spaces between celestial bodies. During the quiet hours of deep sleep, memories drift and settle like cosmic dust, forming new patterns, new connections. Thoughts that seemed unrelated during wakefulness suddenly find themselves drawn together by gravitational forces we don't yet fully understand. Consider how dreams reorganize our experiences, much like how Saturn's rings constantly reshape themselves through gravitational resonances. A conversation from Tuesday might find itself orbiting around a childhood memory, while a fleeting emotion becomes the shepherd moon that guides an entire sequence of dream imagery. The mind, like Saturn's ring system, is never truly at rest, always sorting, always rearranging, always creating new harmonies from apparent chaos. The phenomenon becomes even more intriguing when we consider the dreams of those who spend their lives studying the cosmos. Astronomers and planetary scientists often report dreams populated by the very worlds they observe through their telescopes. Dr. Carolyn Porco, who spent decades studying Saturn through the Cassini mission, once shared how Saturn's rings would appear in her dreams not as distant objects of study, but as intimate companions, their ice particles whispering secrets that her waking mind struggled to remember upon rising. These cosmic dreams seem to tap into something fundamental about human consciousness, something that resonates with the ancient rhythms of the universe. When we dream of floating through Saturn's rings, of dancing with its moons, of hearing the planet's radio songs as lullabies, we're not just imagining impossible scenarios. We're participating in a dialogue between mind and cosmos that has been ongoing since the first human looked up at the night sky and wondered. There's a particular quality to dreams that occur during the quiet hours before dawn, when Earth's rotation carries us toward the part of our orbit where Saturn might be visible. Sleep researchers have noted that dreams in these pre-dawn hours often take on a more expansive quality, as if the dreaming mind somehow senses its position in the cosmic dance. The brain's default mode network, that constellation of regions active during rest and introspection, seems to resonate with rhythms that extend far beyond our terrestrial experience. In these expanded dream states, time itself becomes fluid, much like the temporal distortions experienced near massive objects in space. A dream that feels like it lasts for hours might occupy only minutes of REM sleep, while brief dream fragments can feel like glimpses of eternity. This elasticity of subjective time in dreams mirrors the way Saturn's gravitational field warps space-time itself, creating pockets where moments stretch and compress according to invisible forces. The emotional content of space-inspired dreams often carries a particular poignancy. Dreamers report feelings of profound connection, of belonging to something vast and magnificent. These are not the anxiety dreams of falling or being chased, but dreams of floating, of being held gently by forces beyond comprehension. It's as if the dreaming mind recognizes its cosmic heritage, remembers that every atom in our bodies was forged in the nuclear furnaces of ancient stars, that we are quite literally made of the same materials that form Saturn's moons and rings. When we dream of space, we dream of home in the deepest sense. Not the home of our birth, but the home of our elements, the stellar nurseries where carbon and oxygen and iron first danced together in the cosmic waltz that would eventually lead to consciousness, to wonder, to this very moment of contemplation. These dreams often leave us with a sense of peace that's difficult to articulate, a feeling that despite all the chaos and uncertainty of earthly existence, we are part of something beautiful, something ordered, something that makes sense on scales we can barely imagine. The REM sleep during which these cosmic dreams most often occur coincides with increased activity in the brain's visual cortex, the same regions that process the stunning images we receive from space telescopes. It's as if the dreaming brain uses the same neural pathways that allow us to marvel at Saturn's beauty during waking hours, but freed from the constraints of actual photons and telescope mirrors. These pathways can create visions of impossible beauty, of Saturn's rings seen from impossible angles, of music made from the gravitational resonances between shepherd moons. Scientists studying the relationship between sleep and spatial memory have discovered that the brain's ability to navigate three-dimensional space is closely tied to the same neural networks involved in dreaming. This suggests that when we dream of moving through Saturn's ring system, of navigating between its moons, we're not just fantasizing, but actually exercising fundamental cognitive abilities that helped our ancestors navigate by the stars, that help us today understand our place in the cosmic neighborhood. The timing of these dreams often corresponds with Saturn's position in Earth's sky, as if some ancient part of our brain still keeps track of celestial movements, still responds to the gravitational whispers of distant worlds. Indigenous cultures around the world have long recognized this connection between dreams and celestial cycles, understanding that the dreaming mind is somehow attuned to rhythms that extend far beyond the boundaries of our small planet. As we continue our gentle drift towards sleep, carried by the gravitational currents of fatigue and peace, we join a cosmic community of dreamers. Somewhere above us, astronauts float in their orbital dreams, their minds perhaps visiting Saturn's moons while their bodies circle Earth. Somewhere below us, in the deep ocean where conditions might mirror those on Titan or Enceladus. Marine biologists dream of discovering life in the most unlikely places. And somewhere in the vast spaces between, particles of cosmic dust carry within their ancient structures the same elements that allow us to dream, to wonder, to feel connected to the infinite. The boundary between dreaming and cosmic contemplation dissolves as we recognize that both are forms of exploration. Both are ways of traveling beyond the immediate confines of our earthly existence. In dreams, we are all astronauts, all cosmic voyagers, all participants in the grand adventure of consciousness, experiencing itself through the lens of stardust, organized into the miracle of a dreaming mind. As we drift deeper into Saturn's cosmic ballet, we find ourselves surrounded by some of the most extraordinary moons in our solar system. Each one tells its own story, carved by ice and fire, shaped by gravity's gentle hand and the slow dance of orbital mechanics. These aren't just distant rocks circling a gas giant. They're worlds in their own right, each harboring mysteries that have captivated astronomers and dreamers alike. Let's begin with Titan, Saturn's largest moon and perhaps its most intriguing child. Titan is bigger than Mercury, wrapped in a thick orange atmosphere that hides its surface like a cosmic veil. This atmosphere is mostly nitrogen, much like Earth's, but with a twist. It's laced with methane and other hydrocarbons that create a perpetual haze. If you could stand on Titan's surface, the sky would glow a dusky orange, and the air pressure would feel familiar, though you'd certainly need a breathing apparatus and some very warm clothing. What makes Titan truly remarkable are its lakes and rivers. Not of water, mind you, but of liquid methane and ethane. These hydrocarbon seas dot the moon's polar regions, creating landscapes that are both alien and oddly familiar. Imagine standing beside a lake of liquid natural gas, watching waves lap against shores of water ice as hard as granite. The largest of these lakes, Kraken Mare, is larger than the Caspian Sea on Earth. Rain falls from Titan's skies, though it's methane rain that patters down in droplets larger than Earth's raindrops, falling slowly in the moon's low gravity. Beneath this alien surface, scientists believe Titan harbors an ocean of liquid water, kept warm by tidal heating from Saturn's gravitational embrace. This subsurface ocean might be twice the volume of all Earth's oceans combined, raising tantalizing questions about whether life could exist in these hidden depths. It's a world within a world, where chemistry experiments have been running for billions of years in conditions we're only beginning to understand. Then there's Enceladus, small and bright, reflecting sunlight like a polished marble. At first glance, you might think it's just another ice-covered moon, but Enceladus holds one of the solar system's most spectacular secrets. From its south polar region, enormous geysers of water vapor and ice particles shoot hundreds of kilometers into space, creating a gossamer plume that feeds Saturn's E-ring. These aren't gentle springs. They're powerful eruptions that speak of an active, dynamic world beneath that pristine, icy surface. The source of these geysers is another subsurface ocean, this one definitely liquid and possibly quite deep. The moon's interior is kept warm by tidal flexing. As Enceladus orbits Saturn, the planet's gravity stretches and squeezes the moon, generating heat through friction. This process has kept the ocean liquid for millions, possibly billions of years. The Cassini spacecraft flew through these plumes, tasting their contents and finding not just water, but organic compounds and minerals that could provide the ingredients for life. In the darkness beneath Enceladus's ice shell, hydrothermal vents might be warming the ocean floor, creating conditions remarkably similar to those around Earth's deep-sea vents where life thrives. Moving outward, we encounter Iapetus, one of Saturn's most visually striking moons. Iapetus is a study in contrasts, quite literally. One hemisphere is as dark as charcoal, while the other is as bright as fresh snow. This two-toned appearance puzzled astronomers for centuries. The dark material, called Phoebe-like material after another of Saturn's moons, likely comes from dust swept up as Iapetus orbits through Saturn's distant reaches. Over millions of years, this dark dust has been deposited on the moon's leading hemisphere, while the trailing hemisphere remains pristine and icy. But Iapetus has another peculiarity, a ridge that runs along its equator like a cosmic walnut. This ridge rises up to 20 kilometers high in places, making Iapetus one of the most dramatically shaped objects in the solar system. How this ridge formed remains a mystery. Perhaps it's the remnant of a collapsed ring system, or maybe it formed when the moon was spinning much faster in its youth and then gradually slowed down, leaving this equatorial bulge as a fossil of its more energetic past. Mimas, sometimes called the Death Star moon for its resemblance to the space station from Star Wars, bears one of the largest impact craters relative to its size in the solar system. The crater Herschel is nearly one-third the diameter of the moon itself, suggesting that whatever created it nearly shattered Mimas entirely. The impact must have been catastrophic, sending shockwaves around the entire moon. If the impactor had been just slightly larger, Mimas might have been destroyed completely, scattered as debris around Saturn rather than surviving as the battered but intact moon we see today. Despite its small size, Mimas plays an important role in Saturn's ring system. Its gravitational influence creates the Cassini division, the largest gap in Saturn's rings. As ring particles orbit Saturn, those that find themselves in orbital resonance with Mimas, completing exactly 2 orbits for every one of Mimas's, get nudged and perturbed until they're pushed out of that region entirely. It's like a cosmic street sweeper, clearing a path through the rings with nothing but gravity. Then there's Hyperion, perhaps the most chaotic object in the solar system. This small, irregularly shaped moon tumbles through space in an unpredictable rotation, never showing the same face to Saturn twice in the same way. Its surface is pockmarked with craters that give it a sponge-like appearance, and its low density suggests it's more like a loose pile of rubble held together by gravity than a solid rock. Hyperion's chaotic rotation is caused by its irregular shape and the gravitational influences of nearby Titan. It's essentially tumbling through space like a cosmic football, impossible to predict which way it will be pointing from one orbit to the next. Among Saturn's more distant moons, we find Phoebe, which orbits backward, retrograde, compared to most of Saturn's other moons. This suggests that Phoebe is likely a captured asteroid or Kuiper Belt object, pulled into Saturn's gravitational embrace during the early days of the solar system. Its dark, heavily cratered surface tells of a violent past, and it may be the source of much of the dark material that has painted Iapetus's leading hemisphere. Some of Saturn's smaller moons exist in even more unusual arrangements. Janus and Epimetheus are co-orbital moons, sharing nearly the same orbit around Saturn. Every few years, the inner moon catches up to the outer one, and they exchange places through a gravitational dance that swaps their orbits. It's like a cosmic shell game played out over decades, with 2 small moons trading positions in their endless waltz around the planet. The shepherd moons, including Prometheus and Pandora, work together to keep Saturn's F-ring in line. These small moons orbit just inside and outside the narrow F-ring, their gravitational influences preventing the ring particles from spreading outward or falling inward. They're like cosmic border collies, herding the ring particles and occasionally creating knots, braids, and other structures in the ring through their gravitational choreography. What's remarkable about all these moons is how they interact with each other and with Saturn itself through gravitational resonances. Many of Saturn's moons are locked in precise orbital relationships. For every 2 orbits one moon makes, another might make exactly 3 or 4 or some other simple ratio. These resonances create a kind of celestial clockwork, where the moon's gravitational influences on each other help maintain stable orbits over billions of years. The diversity among Saturn's moons speaks to the complex history of the Saturn system. Some, like Titan and Enceladus, formed along with Saturn from the same disk of material that created the planet. Others, like Phoebe, were likely captured later as the solar system evolved. Still others might be fragments of larger moons that were shattered by impacts or tidal forces, creating families of smaller objects that still orbit together. Each moon carries within its geology and chemistry a record of the processes that shaped the Saturn system. The heavily cratered surfaces of some moons speak of the late heavy bombardment, when asteroids and comets rained down on the inner solar system. The smooth, relatively crater-free regions on others suggest recent geological activity, surfaces renewed by internal processes that erase the scars of ancient impacts. As we continue our gentle journey through Saturn's realm, these moons remind us that planetary systems are not static, unchanging displays. They're dynamic, evolving communities where gravity, chemistry, and time work together to create an endless variety of worlds. From Titan's methane lakes to Enceladus's water geysers, from Iapetus's two-toned face to Hyperion's chaotic tumble, each moon is a unique experiment in planetary formation, a testament to the creative power of physics operating over cosmic time. Here is part 11 of the 12-part script for the sleepy scientist. Saturn's Symphony, Rings, Moons, and Mysteries. As we drift deeper into Saturn's realm, watching the delicate interplay of ice and shadow, gravity and motion, we begin to see something profound emerging from all this cosmic choreography. This isn't just a collection of objects orbiting a distant planet. This is a symphony, a grand celestial composition where every moon, every ring particle, every gravitational nudge contributes to something larger than itself. Saturn's system doesn't simply exist, it performs. And tonight we're settling into the best seats in the universe to listen. Think of it this way. If Jupiter is the solar system's protective giant, standing guard against wandering asteroids and comets, then Saturn is its composer, its artist, its gentle dreamer spinning stories of ice and time. Every element we've encountered on our journey, from the shepherd moons keeping the rings in line, to Titan's methane lakes reflecting alien sunlight, from Enceladus's geysers painting space with possibility, to the ancient cratered face of Mimas. They're all instruments in this vast orchestra. The conductor of this symphony is gravity itself, that patient, invisible hand we've spoken of so often tonight. It doesn't wave a baton or tap a podium, but its influence flows through every corner of Saturn's domain. Gravity shapes the rings into their elegant bands, separates them with dark gaps, and keeps billions of ice particles dancing in formation. It guides the moons through their ancient orbits, some quick and close like the inner shepherds, others slow and distant like the captured wanderers from the outer solar system. But gravity doesn't work alone. Resonances, those mathematical harmonies we discovered earlier, add rhythm and structure to the composition. When Mimas completes 2 orbits for every one of Cassini's particles, when shepherd moons clear gaps with their persistent gravitational tugging, when ring particles cluster and separate in patterns that repeat with clockwork precision. They're creating what scientists sometimes call orbital music. Not sound, of course, for space is silent, but relationships so regular, so predictable, that they feel almost musical to our pattern-seeking minds. The moons themselves each contribute their own voice to this celestial choir. Titan hums with atmospheric complexity, its thick orange haze hiding lakes and rivers that mirror our own Earth's water cycle, just written in methane and ethane instead. Enceladus sings with the high, clear note of possibility, its geysers carrying whispers of a hidden ocean that might, just might, harbor life. The Iapetus offers a deeper, more mysterious tone, half bright and half dark, wearing its ancient equatorial ridge like a crown that speaks of forces we're still trying to understand. Even the smaller moons add their subtle harmonies. Hyperion tumbles chaotically through space, its rotation a kind of cosmic jazz improvisation that breaks the regular patterns with delightful unpredictability. The co-orbital moons Janus and Epimetheus perform their gravitational dance, switching places every few years in a ballet that would make any choreographer weep with envy. And scattered throughout the system, dozens of tiny moonlets and ring particles follow their own quiet paths, each one a note in the grand composition. The rings themselves are perhaps the most beautiful section of this symphony. They catch and scatter sunlight like cosmic wind chimes, each particle a tiny mirror reflecting Saturn's warm glow. The A-ring sparkles with youthful energy, its particles relatively close together, creating dense, bright bands. The B-ring, the most massive and opaque, plays the deep bass notes of the composition, its thick collection of ice chunks creating a wall of light when viewed from the right angle. The ethereal C-ring whispers its presence, so translucent that Saturn's disk shows through like a ghost. And then there are the gaps, the pauses in this celestial music that are just as important as the notes themselves. The Cassini division, that dark band between the A and B rings that we can see even from Earth with a small telescope, isn't empty space, but a region where particles are rare, swept clean by resonant forces. It's like the rest between movements in a symphony, a moment of relative quiet that makes the surrounding brightness all the more striking. What makes this symphony particularly poignant is its impermanence. These rings, so iconic and seemingly eternal, are actually quite young in cosmic terms and gradually spiraling inward toward Saturn. Every day, tons of ring material rain down onto the planet's upper atmosphere, pulled inexorably by gravity and slowed by the faint drag of Saturn's magnetic field. The rings are slowly but steadily disappearing, grain by grain, like a sandcastle being claimed by an incoming tide. This transience adds a bittersweet note to Saturn's song. We're witnessing something fleeting, a cosmic moment that began perhaps only a few 100 million years ago, and will end in another few 100 million years. In the grand sweep of solar system history, Saturn's rings are like cherry blossoms, beautiful precisely because they don't last forever. Future generations of astronomers, should they exist, may look up at Saturn and see only a pale, ringless disk, wondering what it might have been like to witness the spectacle we can observe tonight. But for now, the symphony continues. The moon's orbit, the rings spin, the particles dance their ancient patterns. Cassini's 13-year mission gave us front-row seats to this performance, revealing details and subtleties that earlier astronomers could only dream of. We learned that the rings have their own weather, with strange spoke-like features that appear and disappear like shadows on a sundial. We discovered that some of Saturn's moons are geologically active, their surfaces constantly renewed by internal forces. We found that the system is far more complex and dynamic than anyone had imagined. And perhaps most remarkably, we realized that Saturn's system might be teaching us something profound about our own cosmic neighborhood. The processes that shape Saturn's rings, the gravitational interactions that guide its moons, the delicate balance between order and chaos that characterizes its entire domain. These same forces are at work throughout the solar system. Every planet with moons, every asteroid belt, every collection of cosmic debris follows similar patterns, dances to similar rhythms. Saturn's symphony, in other words, isn't unique. It's part of a much larger composition, a universal music that plays wherever gravity gathers matter into orbital relationships. Our own Earth-Moon system contributes its own quiet duet to this cosmic orchestra. The asteroid belt between Mars and Jupiter adds its scattered percussion section. Even the Kuiper belt, far beyond Neptune, maintains its own distant, slow-tempo movement in this grand celestial symphony. As you drift towards sleep tonight, perhaps you can imagine yourself floating high above Saturn's North Pole, looking down at the hexagonal storm that has been raging there for decades, a six-sided eye in a golden hurricane. The rings spread out below you like a vast cosmic record player, spinning slowly in the pale sunlight. The moons trace their ancient paths through space, each one a world with its own story, its own contribution to the symphony. As we approach the culmination of our cosmic journey, dear fellow traveler, the symphony we have followed reaches its most profound movement. We've traced Saturn's story from its birth in the stellar nursery to its present-day majesty, but now we must gaze beyond the immediate beauty and contemplate something both humbling and magnificent: Saturn's place in the grand, ever-unfolding story of time itself. You see, Saturn's rings, those ethereal bands that have captivated humanity for centuries, are not eternal. They shimmer and dance in the sunlight now, but they are slowly, inexorably spiraling inward toward the planet. Each particle of ice, each fragment of rock, gradually loses energy through countless tiny collisions and gravitational interactions. Scientists estimate that Saturn's rings may have only another 100 million years or so before they fade into memory, consumed by the very planet they once adorned. It's a bittersweet realization, like learning that a favorite song will one day be played for the last time. But there's profound beauty in this impermanence. Saturn's rings are not diminished by their temporary nature. They are made more precious by it. Every photograph we take, every moment we spend marveling at their structure, becomes a celebration of something fleeting and therefore infinitely valuable. The moons, too, dance their slow waltz toward uncertain futures. Enceladus may continue to spew its geysers for millions of years, but eventually its internal heat will fade, and those magnificent plumes will fall silent. Titan's thick atmosphere will gradually leak away into space, its methane lakes will evaporate, and its orange haze will clear to reveal a cold, airless world. Even mighty Titan, with all its Earth-like processes, is not immune to the patient hand of time. But this is not a story of endings. It's a story of transformation. The ice from Saturn's rings won't simply disappear. It will become part of Saturn itself, perhaps contributing to new atmospheric phenomena we haven't yet imagined. The materials from the moons will continue their cosmic journey, perhaps one day becoming part of new worlds, new systems, new possibilities we cannot yet foresee. Saturn itself will continue to evolve. As our sun ages and gradually brightens over the next billion years, Saturn's delicate balance will shift. The planet's atmosphere may change, Its storms may intensify or calm. Its magnetic field may fluctuate in ways that create entirely new auroral displays. The hexagonal storm at Saturn's North Pole, that geometric marvel that seems almost artificial in its precision, may one day dissipate, replaced by new patterns we haven't yet observed. And then, in the far distant future, when our sun begins its final transformation into a red giant star, Saturn will face its ultimate test. The sun will swell to enormous proportions, its outer layers reaching perhaps as far as Earth's current orbit. Saturn, thankfully positioned much farther out, will likely survive this solar death throes, but it will be forever changed. The intense radiation may strip away some of its atmosphere, alter the chemistry of its remaining moons, and create an entirely different world from the Saturn we know and love today. Even after our sun dies, shrinking into a white dwarf star no larger than Earth but incredibly dense and hot, Saturn will continue its patient orbit through a much colder, darker solar system. Its remaining moons will become frozen worlds, their surfaces unmarked by the geological activity we see today. The planet itself will radiate its internal heat into the cosmic void, gradually cooling over billions of years until it reaches equilibrium with the near absolute zero of interstellar space. But even this is not the end of the story. Saturn, along with all matter in the universe, participates in cycles far grander than planetary evolution. The atoms that make up Saturn today, its hydrogen and helium, the water ice in its rings, the complex organic molecules in Titan's atmosphere, all of these were forged in the hearts of ancient stars. They have been recycled through countless stellar generations, and they will continue this cosmic recycling for eons to come. Perhaps billions of years from now, when our galaxy collides with Andromeda and new stars are born from the gravitational chaos, some of Saturn's atoms will find themselves in entirely new solar systems. The hydrogen that once swirled in Saturn's atmosphere might become part of a new star. The water ice from Enceladus's geysers might one day fall as rain on an alien world. The methane from Titan's lakes might become part of organic compounds that, in ways we cannot imagine, contribute to new forms of life in distant corners of the cosmos. This is the ultimate poetry of Saturn's story. Nothing is ever truly lost, only transformed. The planet we've explored together in our gentle journey is not separate from the universe. It is the universe expressing itself in one particular magnificent way. Every ring particle, every moon, every swirling storm is part of an endless cosmic dance of matter and energy, creation and transformation, order and chaos. And in contemplating Saturn's deep future, we're reminded of our own place in this vast tapestry. We are made of the same stellar materials as Saturn. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of it was forged in stars and scattered through space to eventually become part of us. We are not observers of the cosmic story. We are participants in it. Brief but brilliant expressions of the universe's capacity for awareness, wonder, and love. So as you drift towards sleep tonight, carry with you this final, comforting thought. Saturn's rings may be temporary, but the beauty they represent is eternal. The capacity for ice and rock to arrange themselves into structures of breathtaking elegance, the ability of matter to organize itself into complex, dynamic systems, the universe's endless creativity in finding new ways to express order and beauty. These are not accidents or anomalies. They are fundamental features of reality itself. Saturn is not just a planet. It's a love letter from the cosmos, written in ice and light, storms and gravity, time and transformation. And you, dear listener, are the intended recipient of that letter. You are the eyes through which Saturn sees itself, the mind through which it contemplates its own beauty, the heart through which it experiences wonder at its own existence. Rest well, knowing that you are part of something infinitely larger and more beautiful than yourself, yet you are also absolutely essential to the story. Without consciousness, without awareness, without the capacity for wonder that you possess, the universe would be magnificent but unobserved, beautiful but unappreciated, profound but unknown to itself. Saturn's symphony continues, its rings still dancing, its moons still singing their gravitational harmonies, and somewhere in that cosmic music, your own quiet melody plays on, adding its unique voice to the eternal song of existence. Sleep now, and let the stars keep watch, as they always have, as they always will.